All right, in this video we are going to be working through the first part of the Similarity test review packet. So our first set of problems have to do with solving proportions algebraically. In our first example, we have 2x plus 11 over 4 is equal to 50x minus 4 over 7. So usually our approach here is that we're going to want to get rid of the denominators by multiplying both sides of the equation by each denominator. So first I can multiply both sides by 4. When I multiply and divide by 4, this cancels. So you're left with 2x plus 11 equals the 4 distributes to each of these terms in the numerator. So we end up with 200x minus 16 over 7. So I've effectively gotten 4 out of the denominator. Now I want to get 7 out of the denominator. So I'm going to multiply both sides of my equation by 7. When I multiply by 7 and divide by 7, it effectively cancels. Here I need to make sure I'm multiplying everything by 7, so it needs to distribute to each term. And we get 14x plus 77 is equal to 200x minus 16. Now I want to get all my x's on one side and all my constant numbers on the other. So I can add 16 to both sides, and I can also subtract 14x from both sides. Okay, minus and plus 16 cancel. 14x minus 14x is 0, also cancels. 77 plus 16 gives us 93. 200 minus 14, 200 minus 10 is 190, 190 minus 4 is 186. So we end up with 93 equals 186x. I want to isolate x, so I'm able to divide both sides by 186. And 93 divided by 186 is 1 over 2. They have a common factor of 93. So we are able to solve and find that x is equal to 1/2. Big idea from that problem is we wanted to clear our denominators, get all the x's together, and then isolate for x. Our second problem is similar, except this time x is in the denominator. So we're going to actually have to multiply by the entire expression on the bottom. So I will multiply both sides by x plus 7, which I will put in parentheses to remind that that whole thing is being multiplied. On the left, if I multiply and divide by the same thing, we effectively cancel. So we get 5 equals. Then I want to make sure to distribute this 7 to both terms, x and the other 7. So I'm left with 7x plus 49 all over 17 minus x. I want to clear x out of my other denominator. So I'm going to multiply both sides by 17 minus x, making sure to distribute it fully. Multiplying and dividing cancels. 5 times 17, well, 5 times 10 is 50. 5 times 7 is 35. 50 and 35 gives me 85. And then minus x times 5 is minus 5x. And then on the left-hand side of the equation, we have 7x plus 49. Now I want to get all my x's together and all my constants together. I will subtract 49 from both sides. Okay. 85, 49 minus 49. So 85 minus 50 would be 35. But we are subtracting 49, so we instead get 36. One more. And here we will add 5x to both sides. And we are left with 12x equals 36. And then finally we divide by 12, and we get x is equal to 3. Okay, so same idea, even if x is in the denominator, we want to clear it out of the denominator and then isolate it and solve for it. In these next examples, you'll notice that we don't have such obvious proportions, although one thing we could do is we could consider this as a numerator over 1, and so we have the proportion of 4x plus 1 over 1 equals 6x over 7. That's not necessarily helpful in this case, but it is good to just remember that any expression without a denominator is like it is over 1. But in our case here, it's easier just to multiply both sides by 7, clearing our denominator, making sure to distribute this 7 to both terms. So we get 28x plus 7 equals 6x. And here we would like to get all our x's on one side and all our constants on the other. So I'm going to subtract 28x from both sides, and I get 7 equals negative 22x, divide by negative 22, and we will leave it as x equals negative 7 over 22, an exact answer. Because 7 and 22 have no common factors, we cannot further reduce this proportion. And then our final example is similar, however we have 3x in the denominator. No problem, we could put this 60 over a 1, and this is our proportion. 5 over 3x equals 60 over 1, but we don't actually need to do that. We could also just multiply by 3x on both sides, and we get 5 equals 180x. We divide by 180, and 5 over 180 is equal to x. Now, 180 is divisible by 5. Let's see. It should be 5 goes into 100 20 times, and 5 goes into 80 16 times. So we should get 36. Or 1 over 36 is equal to x. Okay, so we can reduce our proportion, and we leave it as such. Alrighty, moving right along. The angles of a triangle are in the ratio of 3, 4 to 11. Find the measure of each angle. So here, I want to make a diagram to support my thinking. And I know that the angles are in the ratio of 3, 4, and 11. And they are not necessarily 3, 4, and 11 degrees, but that is their ratio. So we're going to put in these x's to help us solve for what these angles actually are. And then we can say that 3x plus 4x plus 11x equals 180, because we know there are 180 total degrees in a triangle. We combine all of our x terms, and we get 18x equals 180, divide by 18, and we're left with x equals 10. But the problem asks us to find the measure of each angle, so we need to substitute that back in for x, and we will get x, or each angle, we'll say angle 1, angle 2, angle 3. So angle 1 would be 3 times 10, or 30 degrees. Angle 2 would be 4 times 10, or 40 degrees. And angle 3 would be 11 times 10, or 110 degrees. These angles are in the ratio of 3 to 4 to 11, and they add to 180, which is a requirement of angles in a triangle. Our next problem is similar. It says the angles of a triangle are in the ratio of 2 to 4 to 8. So we're going to model this, build our triangle again, and we have 2, 4, and 8. And we want to call it 2x, 4x, and 8x. Now we know that 2x plus 4x plus 8x must equal 180. We'll combine our terms, so we get 14x equals 180. We can divide both sides of our equation by 14, and I'll check, but I do not believe that 14 is going to go cleanly into 180. It does not. So we want to reduce this as much as possible. And so 14 has factors of 2 and 7, and 180 shares that factor of 2. So we can reduce these to being 90 over 7. And that is the simplest exact form that we can get. So if we want to find the measure of each angle, we can substitute that back in. So for example, our 2x, we can say 2 times 90 over 7 equals 180 over 7. That would be our angle 1 expressed exactly. Angle 2 would be 4 times 90 over 7. And 4 times 90 gives us 360 over 7, which is the most simplified form. And 8 times 90 over 7 gives us 720 over 7, which is also fully simplified. And you might wonder, how do I know those are fully simplified? Well, 90 over 7 was already simplified fully, and we are multiplying by 2, 4, and 8. So we're not really adding in any sort of factor of 7. So there's no way that 2 times 90, which has no 7s as factors, is equal to 180. We're not going to have 7 as a new factor. We haven't changed this 90 in any such way that we've incorporated a 7, right? Same thing with our 4. 4 times 90, well, 90 has no factor that is 7, and adding in the 4 as a new factor doesn't help us out at all. And same thing with 8 times 90. So that is sort of how I know that those should not simplify. Okay, now you could choose to turn these into decimals if you want at this stage. You shouldn't really ever use decimals until the very, very end. And then we could say which is approximately equal to 25.71 degrees. 360 divided by 7 would be approximately 51.43 degrees. And this is approximately 102.86 degrees. So generally, if it doesn't specify, 2 decimal places is a pretty decent place to round to, but we should not turn these into decimals until the very, very end. We don't want to round along the way. Okay, so let's do one more in this video. So we're going to do number 4. It says polygon PQRS is dilated by a scale factor of 2/3 to form its image P prime, Q prime, R prime, S prime. If the perimeter of P prime, Q prime, R prime, S prime is 18 centimeters, what is the perimeter of PQRS? Okay, so we know that dilations form similar figures. Dilations form similar figures. And our scale factor K is 2/3, and this is our one-dimensional scale factor. We can model this. Maybe we have some quadrilateral four-sided shape, PQRS. And dilating by a scale factor of 2/3 means this is getting smaller. So we get some smaller version, P prime, Q prime, R prime, S prime. And so to get there, we know that we've multiplied by 2/3 in one dimension. So our side lengths are getting scaled by 2/3, as is our perimeter. And we are given the perimeter of P prime, Q prime, R prime, S prime. So we're given the perimeter of our image, or our second shape here. So we'd have to go backwards to figure out what the original perimeter of PQRS is. Now there's a couple of ways to do this, but my recommendation is to set up a proportion. So we know that the scale factor is 2/3, right? The one-dimensional scale factor is 2/3. And that must be equal to the perimeter of the smaller figure, P prime, Q prime, R prime, S prime, 18, over the perimeter of PQRS. So I'm going to call that X. Some X is the perimeter of PQRS. And now using this proportion, we can solve to figure out what that perimeter must be. And just like we did before, we could multiply both sides by X, get X out of the denominator. So we get 2X over 3 is 18. We get 3 out of the denominator. We get 2X equals 3 times 10 is 30. 3 times 8 is 24, so 54. And then X is equal to 54 divided by 2, which is 27. Okay, and we can confirm this, right? The ratio of 2 to 3 is equivalent to 18 to 27. This is true. And we could also say that 27, if this is our original scale factor, or sorry, if that's our original perimeter, and we multiply it by a dilation scale factor of 2/3, 2/3 of 27 is going to give us 18. So we're able to check and verify that our math makes sense here. Okay, if the area of PQRS is 180 square centimeters, what is the area of P prime, Q prime, R prime, S prime? So now we have to think about how area scales. We are given a scale factor, right? K is 2/3 in one dimension, but area is a two-dimensional measurement. So we need to account for the fact that that scale factor is happening in 2 dimensions, and to do this, we take our scale factor, 2/3, and we can square it. So 2/3 squared is equivalent to 2 squared over 3 squared, which is equivalent to 4 over 9. And the 4 over 9 is our scaling in 2 dimensions of the area. So that means if our original area is 180 centimeters squared, we are multiplying that by our scalar of 4/9, and that should equal our area of P prime, Q prime, R prime, S prime. And so you could just multiply 180 by 4/9, and you would be good to go. You could also do this with a proportion. So you could say 180, and let's call the area of P prime, Q prime, R prime, S prime, we can just call that A, over A is equal to 4 over 9. So we can use our proportion to solve. We could multiply both sides by A, and we get 180 equals 4A over 9. I have a mistake here. Okay, so hopefully we caught that. 180 over A. So if I'm taking my scale of 180 over A, the area of our bigger figure, or larger figure, to the area of the smaller figure, P prime, Q prime, R prime, S prime, I need my ratio of the scaling in areas to be 9 over 4. Okay, so that is important. We need to be big to big, small to small. And if that seems confusing, you can always stick with this. So you could do 180 over 1 times 4 over 9. Okay, 180 times 4 is 720 over 9, which gives us 80. If, however, we want to use our proportion, which I do recommend, we can multiply both sides by A now. We get 180 equals 9A over 4. We can multiply by 4. We get 720 equals 9A. We divide by 9. So you'll notice it's the exact same math as we did over here. And we get 80 equals A. So if you do choose to set up a proportion, do make sure that you account for the fact that our scaling has to be big to small over big to small. So I made that mistake, so be careful for that. And we can verify our answer as well. So if the the area of our first one is 180, well, 80 over 180 should equal 4 over 9. And if we reduce these, 80 and 180, we can divide each by 20, and we would get 4 over 9 equals 4 over 9. So we check our work, and we find that we are correct.